What is ARIMA? ARIMA is AutoRegressive Integrated Moving Average models. What is ARIMA? Simply AutoRegressive Moving Average. It is not integrated. ARIMA, A-R-M-A, it is AutoRegressive Moving Average. If it is ARIMA, it is AutoRegressive Integrated Moving Average. Now, moving average, in moving average, we do not use actual moving average, but rather we use errors. We use errors. This you have to keep it in mind. This is ARIMA or ARMA is a forecasting techniques based on exponential smoothing. General assumption for the above models is time series data are represented as the sum of two distinct components. One is deterministic and the second is random. It should be random and deterministic. What is random noise? Generated through independent shocks to the process. Random noise, it's an error, generated through independent shocks to the process. In practice, successive observations show serial dependence. That is the actual. This, say, one error, it depends upon the earlier error. So that is the successive observations. ARIMA models are also known as Box-Jenkins methodology. It is very popular. It is useful, suitable for almost all time series, and many times generate more accurate forecast than other methods. Because we are going to use the single series, so it is usually helpful. Say you want to forecast the price of, say, one company from the historical prices. So it is very good. ARIMA is most popular and it gives you the accurate result, what will be the price of the share. Now, what is the limitation? If there is not enough data, say data is very small, say 7 days data, 8 days data, they may not be better at forecasting than decomposition or exponential smoothing techniques. Recommended number of observations should be at least 30 to 50. There should be weak stationarity in the series. Stationarity there, but can be weak. Equal space between the intervals. Now, this also is one of the assumptions of assumption. Now, we'll have to understand one very important thing. What is white noise? We have got two important stochastic processes. One is white noise. The most simple of all stochastic processes is white noise. In white noise, there are no patterns such as trend, seasons, or cyclic variations. It is sharply a sequence of stochastic variables AT. Now, for instance, YT is equal to AT, where AT is normally distributed between 0 and variance. So this AT has got normally distributed with the mean as 0 and plus your whatever is their variance between 0 and variance. This process is rarely used for forecast, but is an important component for advanced time series models. This process is not useful for forecast because we can't say that YT is equal to AT, and then all YT will be equal to AT. There will be nothing is there. It is just simply moving with a particular number. What is random walk? A random walk means a time series is said to be random walk if YT is equal to YT minus 1, that is a lagged value, plus AT. There is some number with which it is moving, AT. Or a random walk with drift. With a drift, we can say drift means here we are going to add constant. So YT is equal to constant plus YT minus 1 lagged period plus AT, some number which is moving with this, where 80 is the white noise. 80 is the white noise. A random walk is sometimes used for comparison with the other models. So this one, I go back, white noise, yt is simply a number, yt is equal to 80. And 80 is normally distributed between 0 and some variances. It is just moving this. But random walk is some constant. If it is with the drift, it is with the constant and lagged value plus 80. A random walk is sometimes used for comparison with the other models. Why stationarity is important, especially in ARIMA? ARIMA models can be fitted to stationary time series only. Imagine we have 4 observations and each observation has its own mean value and variances. Say variance is 1, 2, 3, 4, then we should have to estimate 8 parameters, which would be impossible. If we instead have the same mean and variance, mu and sigma square, mu is the mean and sigma square for all observations, we will be able to estimate these 2 parameters. ACF function. Now, how it helps us? ACF function helps identifying the moving average models and its appropriate order as it cuts off after lag k. How many lags we are going to use? This will help. ACF function will help. Moving average lags means how many errors we are going to use. So PACF will tell us how many lags we should use for the dependent variable. So there we have got ACF and PACF. That will also help us. But ACF will help us how many moving average, how many lags moving average should we take, and PACF will tell us how many lags of the dependent variable we should. So, but we have to memorize this. ACF tells us how many lags error should be used, that is moving average. Q process, useful tool for identifying order of the process. Cuts off after lag k. So when it stops, it does not further move it. So that is the number of lags we are going to use it. ARP process, mixture of exponential decay and decompose. So fails to provide information about the order of AR. So for AR, we use PACF. So PACF possibly never cuts off. So PACF and of a MAQ process is a mixture of exponential decay and damped sinusoid expressions. In model identification, use both sample ACF and sample PACF. Sample PACF will tell us how many lags of dependent variable should be used, and ACF will tell us how many lags of moving average should be used. We can do it on Eboos. Let us see it. I'm going to start Eboos. Rather, I am going to open one series in Eboos. That is, series is Nifty 2021. The data from 1st December to 30th November 2021. So total there are going to be 247 observations. But for ARMA and ARIMA, we don't need all these series. We need only one series, and we are going to take up only close prices, daily close prices, and we are going to delete open, high, low, and we are also going to delete this turnover and share traded. So we have got now date and closing prices, and we will take up this in our Eboos. In Eboos, it is telling me to see the date and close price. I'll say OK and say next OK, and this data will be there with close date and all. Now, for ARMA and ARIMA, which is also called Box-Jenkins, three stages. First, we will identify, then we will estimate, and then we will diagnose and forecast. If the series is stationary, we are going to use ARMA, and if series is non-stationary, we are going to use ARIMA. ARIMA PDQ. P means how many autoregressive variables are going to be there, lagged variables, and Q, how many moving averages are going to be there. Okay, so let us first see, we can open this file and we can see the prices here. These closing prices are given there. So now let us see first one, quick, and we can go for series statistics unit root. Now unit root, we are going to write it here, the close, say okay. Now first we have to see the level. First we have to see the level and intercept. Let us see first level and intercept. And a null hypothesis close has a unit root because probability value is 0.4768. It is more than 0.05. So we cannot reject the null hypothesis. It means close at level has unit root. Now see the constant here. This constant is 0.081. The probability is 0.0812. If you see the constant here, it is not statistically significant. It is not statistically significant. Now we can use it same view unit root, and we can use trend and investment. We can click on this at level. Now it is again, the probability is 0.52. We cannot reject the null hypothesis. It has a unit root. But if you see this trend, below trend, it is not statistically significant, but constant is statistically significant. Now let us see the same thing, unit root, with a first difference, and we will see the trend and intercept. So here probability is 0.000. It means we can reject the null hypothesis. It means it is reclose, means first difference. At first difference, the series is at level. But here in this case, constant is probability for constant is 0.0533. Though it is slightly more than 0.05, we can consider it as it is significant. It is still, we can say it is near about 0.05. We can take it as, but trend is not significant. Now let us see view, now unit root, and we will say first difference, only intercept. So we will say okay, and now see the intercept is significant. So intercept, we will have to take it up, and the probability is 0.000. We reject the null hypothesis. It means it has no unit root. So first difference, it has no unit root. This is what we have calculated. Now let us see the parallelogram. We will view the parallelogram. In the parallelogram, we will see first parallelogram at level. We'll see the at level parallelogram. So in parallelogram, it is autocorrelation and partial correlation. Autocorrelation is used, how many moving averages we should use. Partial correlation, it tells us how many autoregressive models we are going to use. See, at level, it is there all lags. We have taken up 36 lags. All lags, they are significant, and it goes on reducing and reducing. See, all 36 lags are significant. So it will be a confusion for us at level. But at partial correlation, that's after this one lag, after one lag, it all the lags are, they lie between the dotted lines. That is 95% confidence level. So there is no issue. Let us now see the parallelogram at first difference. First difference, 36 lakhs. Okay, let it be there. Now in the first see, now this will tell us how many lakhs, because we are going to see our series whether we are going to use the first difference. So how many lags we should take. See this first one, first lag in case of autocorrelation and first lag in autocorrelation and partial correlation, they are near the 95% line. So there is no issue. But in case of lag 2, it is again touching this autocorrelation line is spreading, this auto2 correlation line is spreading. So should we, but this is probability for this is less than 0.05. Should we take the model 212, 212, ARIMA 212? ARIMA we are not going to take because our series is not stationary at level. It is stationary at first difference. So our parallelogram at first difference, parallelogram of D close, first difference, it also says that series that with lagged 2, the probability for Q stat is statistically significant. But it also tells us, because this lag 3 of autocorrelation and partial correlations are also significant. So what should we do? We see ARIMA is an art. It is not a science. ARIMA is more of an art than science. Now we will take up the model as AR3 MA3. D close C AR3 MA3. Okay, so let us see now. This is our equation, but in this equation AR3 is not statistically significant, MA3 is statistically significant. We can save this equation as AR3 MA3. If you want, you can also make a model with AR1 MA1. Let us make another model, quick estimate equation with D close C AR1 MA1. So this equation is ARIMA 111. That is autoregression 1, difference is 1. Difference we have taken it up, first difference 1. So MA1 is. So let us see this model. Okay. So we can save this also as AR1 MA1. Now let us compare all the three models. So we have got here AR1, then we have got ARMA3, and we can take it up here this way, ARMA2 and ARMA3. So we have got. Now first thing is see R square. R square in ARA MA1, R square is 0.011. 0.011. But in case of AR MA2, it is 0.054705. So ARA MA2, in ARA MA2, R square is more. In case of AR3 MA3, it is 0.048961, means 0.04. Here again R square is more. So from R square point of view, AR2 MA2 model is good. Let us see now Akaike info criterion. In ARA MA1, AIC Akaiko info criterion is 12.85016. In case of ARMA2, it is 12.8092. It is less. So less is always better. AIC is less is always better. So AR2 MA2 model is okay. But in case of ARA-MA3, it is 12.81. Then again it has increased. It means AR2 MA2 is better. If we see the Schwarz criterion, it is in ARA-MA1, it is 12.89. In case of ARA-MA2, it is 12.85. But in case of ARA-MA3, it is 12.86. So among all the three, 12.85 is the least one. So we can say ARA-MA2 is. So in that case, ARA-MA2, we can select the model. So this model is okay for us. So we don't need now other two models. We will delete them. We don't need it. We don't need it. So we don't require it, though it is there. So now let us see with this model. In this model, first thing is we have to see view ARMA structure. All our ARMA structure, we will see the graph, we will see the roots. If these roots are lying, if these roots are lying in the circle, we will say it is a good model. Otherwise, we'll have to rework on this. We'll say, okay, see the roots are lying in the circle. I feel that we should take both. First, we should have the AR and MA as 3, that is ARIMA 313, and then we should see ARIMA 212, and we should check which one is better for us. Which one is better for us? So let us go to quick estimate equation D. Why we are using D? First difference, because our series is not stationary at level, but our series is stationary at first difference. So D close C AR2 and ARMA2. So we are going to use this. We are going to use this our model as AR2. Our model will be ARIMA 212. ARIMA 212. Let us regress it. We will say okay. Okay, now this is the equation with our AR2 MA2. Agar 212. So we can say ARIMA 212. Now here in this case, R squared is 0.04705. Durbin-Watson is 1.813. So Akaike info criteria is 12.80925. I'm going to save this equation as AR2 MA2. MA2. I'm going to save this equation as AR2 MA2. Okay. We will have to change the range. Now our range is here from 1/12/2020 to 30th 11/2021. So we will have to change this. Now I want to add another say 15 days. So because this one is there, so I am going to say 12 15 2021. 12 15 2021. I'm going to up to 15/12. I'm going to forecast it. I'm going to change the date up to date, and then this one is there. So we are resizing with the 11 more observations. We can say continue. Okay, now if we see the close view, it open it, and we can see the level. In the level, we can see, oh, it has, we can open the close, open as cancel, because it is showing the this one. Okay, now it is showing this one, but the values from higher values, they are showing not available. 12.1. So 12.1, 12.2 they are not showing. So these are not there. Now let us go to forecast. We will go to forecast. First of all, we will select the model AR2 MA2. We are going to select the model. We will go to forecast, and this forecast, it is automatically creating a new forecast series, close F. So let it be there. There are two methods of forecasting. One is dynamic forecast, another is static forecast. So we can use any of the method. We will use dynamic method here, and here we can use this forecasting time, and we can use it from 12/1/2021 12/1/2021 to 12/15/2021. We'll say okay. Now this is the forecast here. So now this red lines, they show us the red lines, they show us the two standard errors. These two standard errors, this is our forecast, blue line is our forecast, but this red lines, they are showing the range of 2.2. Okay, now we can see these tables also. We can open both close and forecasted close values and forecasted values, original values, and we can say open as group. See, now this all these values, they can be seen here, but from 1/12/2021 there are no values, but only the forecasted values are there. So in 1/1/12/2021, the forecasted value is 17,014. Next year is next day is 17,036. So like this, we can have the forecast period. ARIMA forecasts are good forecasts. You can easily forecast it. You can also see the standard deviations range. But one thing you have to keep it in mind, if series is stationary, you use stationary, we use ARMA, that is ARMA PQ, that is number of autoregressions and number of PQ and number of autoregressions. But if series is not stationary, and it can be made stationary, by first difference, then we use ARIMA PQD. Here in this case PDQ. Here in this case, the example which we have seen, we have used ARIMA 212. ARIMA 212. We have used ARIMA 212, means 212 means that is autoregression to PQ means autoregression to differencing 1 and moving average 2. So this is what we have done. Thanks for watching. Thank you very much. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work. Thank you.